Howdy, y'all. Ooh, it's bright. Let me take these glasses off. Thank y'all so much for coming and hearing this talk about this crazy adventure that I got to go on with an amazing team of people. This is an 8-month journey in my life and my colleagues and friends. And what started off as a chance encounter over dinner with some friends and colleagues in Ukraine turned into perhaps one of the most profound events of my professional and personal life. And this journey would lead me on a way to discover more about the humanity of what we connect with in our life and industrial control systems and how it affects others. And it would also lead me to some pretty interesting conclusions about how we rely on the electromagnetic spectrum and GPS to both maintain just civilization writ large, but also how we talk about industrial control systems, especially as it relates to the power grid. So without further ado, let's jump into the good stuff, shall we? So what happened? About this time last year, actually in late February, I was having dinner with some fine folks from Ukrainian. They're the TSO slash, the transmission grid operator for Ukraine. Unlike the United States, where we have a lot of folks that do that, Ukraine is obviously smaller. And they are state-owned, and they have been state-owned for some time. Ukraine's really unique with its power grid, by the way. They have, of course, 50 hertz. We're at 60 here in the United States. They operate at really high kV, so you want 750,000 kV. I think the next closest would be Germany at 400 kV. And of course, during this time last year, if you were watching the news, you were very aware of the kinetic strikes that were attacking the substations, destroying transformers, destroying arresters, just basically creating millions and millions and millions of dollars of damage. And during this dinner, as I was there, and I was just there to give them the cybersecurity brief, I said, hey, what's going on? What's your lived reality? Tell me stories, because all I know is what I see in the news. And they gave me an earful. And it was a very great conversation, not in the sense that they were giving me information, but because they were just happy to be having a great meal with good company, and no one's trying to shoot at them or bomb them, or, and for that moment, I just took that as a moment of refuge. And they were extremely open with me. And they said something to me offhand. They said, between the kinetic strikes, between the cyber attacks, between all of these things, they had a really unique problem. And they were like, we can't get our GPS to work for our synchrophasors, for our grid management, because of electronic warfare jamming. I'm not an electronic warfare expert, I'm not a GPS expert. During my time in my utility days, I was aware of the importance of it, but I really didn't know much about it. I'm a threat researcher, I'm a cybersecurity guy. But I said to myself, well, I work at one of the largest hardware manufacturers in the world. Surely we have something that can do this. And the short answer, no, we didn't. But it really caused me to dig deeper into what was going on inside of Ukraine right now. So a huge electric grid they've got there, right? They have a lot of high voltage bulk transfer power substations, but there's some that are just a little more critical than others. At the time that I talked to them, they'd had 6 completely destroyed, millions and millions and millions of dollars that they were never going to recover. And because they operate at such a high kV, I can't take a 400 kV transformer from, say, Estonia and put it into a 750 kV substation, because it's just not going to work, right? So there were no replacements. So they're making do with what they have. They're spit baling wires and duct taping everything on their electric grid to keep it functioning. They are perhaps one of the only places in the world that I know of right now that are enduring what I call the triple threat. They're being shot at, they're enduring cyber attacks, and they're having the electromagnetic spectrum taken away from them so that the civilian infrastructure that relies on all of that just doesn't work, or it works very, very erratically. So what is electronic warfare? If you're like me, you're familiar with the phrase, perhaps because of the wars we've been involved in, or perhaps your prior service, but I didn't really know much about it. And ultimately, electronic warfare is something that is key A+ of what we see in Ukraine right now, all right? Because you have all these drones, these first-person drones, we have these GPS coordinate-guided munitions, we have all of this electromagnetic spectrum usage to conduct warfare. Well, you have to protect that for my troops and deny it for yours, okay? That's ultimately what electronic warfare is. It is the denial of the electromagnetic spectrum. So think radars, think GPS, think anything along those lines that allows my troops to both tactically coordinate themselves and us to achieve our military objectives and deny the enemy theirs. What you can kind of see on the screen here is just some examples of the Russian electronic warfare arsenal that they have, so to speak. They actually, it's one of these weird things that the Russians are really, really good at electronic warfare. Long ago, I think sometime in the 90s, early 90s, they realized that even when the Soviet Union fell and Russia became Russia, the Russian Federation, they were never going to achieve true force parity with NATO and the United States. So not fighter jet for fighter jet, right? So they chose to invest their money into high return, but ultimately low dollar investment. I don't have to go buy an $80 million jet. I can develop things that are really effective, like missiles, like coordinate guided munitions, like electronic warfare. And they're very, very, very good at it. They've been doing it a very long time. So this electronic warfare is unfortunately a two-way street, right? So I'm going to put you in a position, and if you actually were to go and look at the news right now, you would actually see news reports of this. You would see Russian airstrike happens at 3 in the morning, Kinzhal caliber missiles, Shahad 136 or 172 drones coming in. Air raids last 2 to 4 hours, right? And they can shoot all the way from inside of Russia all the way to Lviv. They have the whole country bracketed. They can send these munitions wherever they want to, and they do. Well, let's say you're a transmission operator. You have to protect your stuff. You're the government. You have to protect your stuff. Well, you have your own counter jamming you can use, right? So I have a situation. I know an airstrike is happening. We've tracked them on our radar. Well, I have to jam myself now because I need to disrupt the ability for these coordinate-guided munitions to be able to blow up my substation. Now, I might disrupt and degrade my ability to transfer power, and I'll explain why in a second, but it's better than seeing it explode, all right? Because I can't replace that. So what we saw, or what I learned, was there's a lot of fratricidal jamming going on in Ukraine right now for them to protect their assets. And they're pretty good at it, but they're really being into, I don't know, the worst of two situations, right? It's really brutal. So they're struggling right now to maintain GPS, and GPS is vital for the transmission grid to operate all over the world, not just in Ukraine, and I'll explain why here in a minute. And you're probably wondering, well, wait a minute, GPS is fragile? Friends, it is incredibly fragile, all right? Maybe the first Spaceballs reference in an S4 presentation, I'm proud of that. So, all right, so GPS is an old technology, 1960s level technology. It is, satellites, I think for the US constellation, the oldest satellite we had was launched in 1997. But this is technology that in some capacity has existed since the 1960s. We have multiple constellations in orbit. So we have Baidu, we have Galileo, we have Gosnav, we have all of these constellations that all ultimately do the same thing. We have a ground control station that sends signals to the satellites. Satellites orbit the Earth. You've got about 30 for the US constellation. And once you find 4 satellites, your phone can tell you where you are, every 2 to 3 minutes. And it's pretty simple. It pretty works. That it's a broadcast, and it is an incredibly weak broadcast. All right, so what is it? Minus 50 or minus 150 decibel milliwatts, which is like from 10,000 miles away, a 50-watt light bulb level of energy transference. So if you have a cell phone, you are participating in the electromagnetic spectrum. You have hypersensitive GPS antennas inside of your phones and your devices to receive that signal so that you can kind of figure out where and when you are. So it's not hard to push over. It really, really isn't. In the electromagnetic spectrum, it's 1,500 megahertz, it's carved out. Everybody knows what it is, and if everybody knows what it is, I can take that away from you. And I'm going to because I know it's going to hurt your military objectives. Electronic warfare is not limited to combat zones. So this happened on December 25th of last year. There was an international temper tantrum, I think, thrown by the Russian and Belarusian governments. And basically, they turned off GPS for half of Poland and parts of Sweden for about 8 hours. And I think in the United States, we're in a very comfortable position because we never have to worry about, is Canada going to attack us with electronic warfare? The answer is no, just hockey. But what they will do, or what an adversary would do if I was in Southeast Asia or if I was in, say, Europe, right? The international borders in electromagnetic spectrum don't mix, and they're never going to, right? So what someone does, say, in Estonia could affect someone in Lithuania, or so on and so on and so on. In this particular case, these were ground control and air interdiction missions that ran, and for reasons I'm still not entirely quite sure, because precision navigation and time was taken away. I actually was able to talk to folks who were directly involved with that and doing triage with it, and it was just one of those, I think we can do it, we're gonna send a message, and I hope you're listening, because what can be given can be taken away. So if civilian infrastructure is being impacted, why is it so valuable? All right, so this is just the basic setup of how precision navigation and time works, all right? We're gonna focus today more on the time, more when you are, less where you are, but we are gonna get a little bit into where. But basically this diagram is just a great example of how this works, all right? Mentioned earlier, you have a ground station. I've got 30 to 32 satellites for the US constellation in orbit. They're not in geostationary orbits, so we're spinning, we're rotating the sun, they're rotating us. It's all this glorious spaghetti mess of trajectories, and the system works really well for all of us. So a TSO or ISO is using that to basically calculate time. And this is just generally what their job is on a good day, right? It's hot somewhere, it's cold here, we're gonna have to either increase supply or we're gonna have to reduce demand. We gotta keep things nice and balanced. We gotta keep the plates spinning, right? Ukrenergo in Ukraine also doing this, but they're also getting shot at while they're doing it. So take weather events, take calamitous events like that, sort of shove them to the side and now worry about landmines, cruise missiles, drones. It's the next level of resiliency that you don't really even think about. And what they're really measuring is this. They're measuring at super basic high level, they're measuring frequencies. I don't want to go too deep into what a phasor is and why that matters, but suffice to say, this is what every substation measures, where they have these special devices planted called PMUs. The PMUs measure, and then they just report back to the main home base, hey, we're seeing a little dip in frequency here. I just want you to know what's going on, and we'll do that every 30 microseconds, thereabouts, all right? And they pick strategic places, and in the case of Ukraine, it's between 40 to 60 locations that are of high importance to them, that they want to do these samples from, and they're gonna do them very fast, very quick, all the time. So what happens when it goes away? Well, it's difficult enough to do on a good day. It's bad enough to do when you're being bombed at 3 in the morning, all right? When I lose the ability to measure that PMU, that phasor, plates don't immediately fall. That's the good news, right? It's not like blackouts and brownouts happen. It's nothing that dramatic, right? But this visibility being stripped away causes your bulk operators to start making really either no choices to balance their electric grid, or they're running off of incomplete data, or they have an islanding situation where they can see here but not there. Why can't I see here? Is EW turned on and denying me visibility? Did it get destroyed? All right, is it just a bad blizzard? I don't know anymore, right? So this level of uncertainty was really giving them a tremendous amount of heartburn in Ukraine, right? And they're making the best with what they did. When I met these folks in San Jose last year, they were actually going to Distributech, and they were talking to all the vendors. Hey, what can you do to help us with this PMU thing? And the answer was, not much, not much. And the hard reality is that ICS equipment sold into the world isn't really designed for a war zone, right? When you install your PMUs or your reclosers or the things that you need to have your bulk grid operate, is it designed to resist EW? Is it designed to resist, certain vibration? It's rugged, of course, but is it meant to go in a war zone where chaos is literally the definition? The answer is probably not, probably not. So their system, their wide area management system in Ukraine was really great. I don't know how you design a system to counteract another nation invading you and hurting your people. So what was time like before Ukraine? So this is the basics, all right? You have a satellite in orbit. It communicates a time. The Grandmaster clock decodes that inside of a substation. If I were to show you a picture of this box, you would be deeply unimpressed. It's very basic. And then that communicates to the substation equipment exactly what time it is. And it's doing it simultaneously all over that country in about 40 to 60 places on the exact same stopwatch. So if Ukraine's transmission grid is 25,000 kilometers long, imagine a marching band 25,000 kilometers long. all spaghettied and crisscrossed. And we need to monitor that. Well, I can't have separate stopwatches to know that the tubas are about to run into the drum set or that the woodwinds are falling behind. I need to have a single source of truth for me at least to make a best estimate or a best collaborative decision on that frequency monitoring based on that clock. And when I start stripping those clocks away, well, bad things start to happen, all right? The Grandmaster clock, the device inside of our substations that uses GPS timing, it stops working. It doesn't know what to do without that signal. The phaser measurement unit device inside of the substations in Ukraine have no idea what to do with the loss of signal, so they throw their hands up in the air and they go, yeah, I'm not gonna work anymore, good luck until this goes away. And that was the problem more or less confronted to me by the Ukrainians. And I'm eating dinner and I'm talking with these guys and I'm going, man, this is a really hard problem. I don't have a good answer for this. And I would walk away with no answers, but I was committed to finding a way to helping them. And immediately after that, I came to S4 last year. And I got to talk to so many of you guys and gals. And I said, hey, I had this really amazing problem with Ukrainians. They're having problems with grid synchronization because of lack of timing. And everyone went, huh, that sounds pretty bad. I don't have any answers. And I was like, yeah, me neither, right? But it felt good to get that validation of, wow, this is a really weird problem. And I don't know what to do about it. Actually, everyone kind of said the same thing I said, which is, hey, just go buy some atomic clocks and bolt them in your substations, which has got to be the most 1% American privileged answer to ever say to anybody. Just go buy a $40,000 clock and put it in your substation. When it gets blown up, go replace it with another one. Yeah, only here could we say something like that, right? Ultimately, atomic clocks were not going to be the answer. But this is just an example of what that actually looks like on a PCAP when synchronization is lost. This is from Ukraine. This is data that basically says synchronization lost, just a nice little show and tell. So what did we do? Well, in March, I got back, and basically I said, this is bullcrap. This is a homicidal maniac who are threatening my friends and their families and their friends inside of country. Talos, we're about 500 of us. About 80 are Ukrainian. All right, these are people that I work with, that I love, that I respect, that I enjoy working with, and I can see their hearts broken in their chests of what they're having to endure. Not just, and what they don't even tell me, like maybe they had a friend who was in the military and they're worried for their safety or they've lost someone. Like, and I just have to put myself in their shoes for 5 seconds and go, if there's something I can do, let's do something, right? So I resolved myself to two things. One, perfect is the enemy of good enough, all right? I can't find atomic clocks, and trust me, I did try, to send there and find some way to scoop the thing into a substation, even though it's never been done before. Couldn't really find that. Couldn't really find that. Second thing I had was, we have to move very fast. Whatever I find inside of this massive ecosystem that is Cisco, we gotta move pretty fast. So I gotta make a bunch of them, I gotta get them to Ukraine. Now I don't know what it is, what it looks like, or really what it can totally do, but damn guys, we gotta have something here. And it turns out we actually did. So this is the IE 5000, Industrial Ethernet 5000. It is a deeply unsexy pizza box with lights and cables. If you've ever seen a switch, you know exactly what this looks like, and it is nothing new to anybody, all right? Interesting thing about this, no, it doesn't have an atomic clock in it, but one of my engineers who I would bring aboard my team would say, hey, it's got a crystal oscillator in it, but it's a really high quality one. It can keep a drum beat really well. And I went, oh, okay, that's interesting. It's ruggedized, it's meant to go in substations. Now what it does not have is firmware inside of it to allow the switch to both talk to this substation equipment, these PMUs, and to be able to really have what we call an enhanced clock recovery algorithm inside of it. We would have to develop all of this. And I also want to clarify, we've never done any of this before. To my knowledge, no one has ever done any of this before because no one has really found themselves in a war zone where they've been countered by EW and have to find out how to keep their GPS working. So let's get it done. So what did we do? Well, we made a sandwich, for lack of a better phrase. So we were able to take our device and basically hook it directly into the GPS, the actual antenna that sits in a substation. And when GPS cuts out for about 2 to 4 hours, so one of the things I had to study was, what's the average air raid duration? It's about 2 to 4 hours. How are they targeting? What munitions are they using? What are the capabilities of those munitions? I didn't want to give them something that wasn't going to work 6 months down the road. I wanted to give them something that had me with an appreciable understanding of Russian electronic warfare, Ukrainian electronic warfare, and the munitions being used. So we took this IE5K and we basically wedged it in between the phaser measurement unit and the GPS antenna. And we don't do anything. GPS is working, the clock is ticking. Cool, great, I'm glad things are working great. When things go sideways and the antenna cuts off, and this took a lot of testing, by the way, we were able to basically say, no, 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 do not panic. Our high quality crystal oscillator, our clock, and these IE5Ks are perfectly capable of accurately keeping that 30 microsecond drumbeat for a long time, longer than 2 to 4 hours, I can tell you that much, right? And of course, we had to test this. So if you ever want to make your own electronic warfare test jamming rig, for about $100,000, it can be yours. This is on our blog, you can go check it out. But basically, we had to make this in Texas to go, are we even within ballpark? And then once we figured out, you know what, we have these switches, we can modify them, development firmware inside of them. Well, we need to get them to Ukraine. Pop quiz, how do you mail something to a war zone? Anyone? Yeah. Yeah, well, in this case, it's your tax dollars. For most of you, we use the United States Air Force. We had our switches transported on a C-5 transport plane from the United States to Rzeszów, Poland, from Poland and to Lviv. We actually got stupid lucky with our government partners who had joined this coalition of awesome people and said, hey, look, there's a humanitarian aid shipment leaving. If you can get these things here in about 3 to 5 days, we can get them on a plane to Ukraine with all this other humanitarian aid that's already going there. And I was like, dope, let's do this. And it's probably one of the best photos I've ever had in my life, where basically we were like, yes, let's do this. We got these things into Ukraine. We actually were able to test in a lab in Ukraine. And they had to assemble spare parts to simulate a substation in their lab. They had no spare parts because they had all been destroyed. So they managed to scrap together just enough, I think literally just one instance of it from the entire country to plug our switches into. And I think they just yanked the cable right out of it. Friends, and it worked. It worked. It took some modification for us to be able to make these switches do this. Now, we needed to be able to talk to the power equipment. Every ICS vendor, and I'm looking at all of you in the audience that I can't see because of the lights, you all have unique snowflake ways of doing things. That's fine, that's cool, I'm not judging you. But we have to be able to reverse engineer that so that our switches would be able to both speak the language you want to hear and make sure we're giving you accurate information. You're thinking, man, that sounds kind of like a hack job. Yeah, it totally is. We actually had to hack our own switches to figure out what were the right metadata tags that the PMU was expecting. And in this particular case, we actually did it. The yellows, and it's a little difficult maybe to see, but the yellows basically were like, no signal detected, but time is synchronized and accurately synchronized. Like, we really, really tested this. The Ukrainians call them the magic boxes. I talk to them on a weekly basis, and you know, Taras, one of my friends and colleagues over there, basically said, it's giving a surgeon a flashlight to operate in a dark operating room that has no power. Like, we're able to suddenly have visibility into our power transmission grid that we lost because of this insane war that we've been plunged into. And I have to tell you, one of the things that made me the happiest in my life was seeing the humanitarian aid shipment. My company put together quite a few of these. We got these built in a week and within Ukraine within a month. And we wasted absolutely no time getting these deployed to all the critical substations inside of Ukraine. And right now, in every substation, you will find our IE5000 Ukraine edition with appropriately cryptographically signed, which I'm admitting so much of what it takes to get proper firmware inside of my company. The amount of bribes, cajoles, and threats I had to do just to get this done was profound. But of the amazing team of people that I had helping, you know, a lot of those people were like, I can get this done for you. Joe, I can get that done for you. I'm in, let's go, let's help these people, let's save lives. So I'm gonna bring this up sort of as an afterthought. Everyone asks me, well, Joe, we've heard a lot about jamming. What about spoofing? What have you got, pal? And spoofing is not the lack of a GPS signal, it's the misrepresentation of a GPS signal. If you pull your phone out now, it would probably say you're at the Lowe's conference room, but what if it says you're in Cuba? What if it says you're in Moscow or St. Petersburg, right? It's pretty easy to fool GPS. It's old tech. You can do it pretty easy. The answer is it's a much more difficult problem to solve, but I am working with the Ukrainians right now to figure out what can we do to mitigate it. The issue is this, because we're spinning around the sun and the Earth is rotating and the satellites rotate around us, you have basically some slack built into GPS that allows us to kind of guesstimate sort of when and where you are, because it's not an exact science. And this is just necessary for the system to function. That can also be abused, right? So something like a capture and drag, or a superimposing of the satellites. I fake a satellite and make you think you're somewhere else. This actually is a little worse than jamming for a substation, for an electric utility, because the actual devices in the substations will tell you, I think we're synchronized, but it says you're 15 miles underground. And the data is corrupted, and now the operator has to look at that data and go, do I trust this? I don't know. I don't know if I can trust this, because I know someone is manipulating the when and the where of what's going on inside of my substation right now. It's almost easier when you don't have it, to be honest with you. And that's the conundrum they find themselves in now. And we are just starting with our kit, which is essentially deployed to the front lines, to figure out what are some interesting mitigations we can do that are low cost effective, that will move fast, and perfect is the enemy of good enough. And we have a great relationship and a great team. I really look forward to being able to pursue this problem on to the next adventure, right, friends? So what are my final thoughts? We're all humans, every one of us. We have lived the human experience, and we've had tragedy and triumphs in our lives. But I'm gonna get off this stage afterwards and go have a cold drink and not think about anyone trying to kill me or my family, all right? Ukrainians don't have that luxury. They really don't. Every time an air raid siren sounds off, or every time they get the bad news that they've lost a loved one, is an unspeakable tragedy that you and I do not have to endure. If you find yourself one night having dinner with someone who's in a bad spot, maybe they run a power grid, just be a good human to them. Just listen to them. Take care of them. And then maybe you don't have the answers then and there, but you will eventually have those answers. But the fact that you were present and you listened means everything, even if you just don't have the answers. That's life. Being here is a privilege. I mentioned when, after I left my meeting with Ukrainians, the TSO guys, and I came here to S4, I was surrounded by an amazing community of amazing, smart, handsome professionals who knew their business cold, and I could validate my thoughts with them. There's such a concentration of knowledge in these halls that when you're having dinner or you're having coffee with someone, ask them, hey, what do you do? Where do you work? What are you working on these days? Just small talk, right? Because you never know when that might help you save some lives. You never know. And remember that and file that away in the back of your brain. Ultimately, what does this mean for GPS? All right, so I haven't terrified you enough already. We put our IE-5000s in Ukraine because we realized that I don't control satellites in orbit. I can't put resistant jamming technology in a substation that stops terrestrial but wouldn't stop an air interdiction mission. I can't control and protect the electromagnetic spectrum as much as I wish, all right? I don't own that, I share it. Well, let's get rid of it. Let's go to, if bad thing happens, it's cool, I've got a local thing that can do the job just fine until it comes back and is stable for me. We had to write off, and not because we wanted to, but because we had to, because war gives clarity that I need solutions that will endure and survive, not highfalutin theories. And that's why we made that decision. We just cut the extraneous out immediately and said, what is the simplest and fastest way we can solve this problem? Now, there could be more elegant solutions down the road, and I hope we do develop those. But if it's dumb and it works, it's not dumb. So when you think about this, when you go back to your places, I hope you think about your electromagnetic resiliency as well. And I think the last but not least is I want to thank the team of people who helped us develop this product, who worked night and day from logistics to phaser expertise, to the Ukrainians who risked life and limb to be able to get us all of these things. They made every bit of the difference. And this is a career magnum opus for me and one I'm so supremely proud of, the help we were able to do. So last and not least, Slava Ukraini.